Hello everyone, welcome to my YouTube channel Algoride. This video talks about algorithms and a very basic introduction about their real world examples on how we really use the algorithms and how they are useful and impacting our day-to-day lives. So in this video, I'm going to present you some kinds of algorithms and their real world examples. And in my future videos, I'll be using programming language like Java to really implement them and also discover about their applications in different kinds of problems. So let's move on to our video. So what is an algorithm? An algorithm is something like a computational task or a procedure which takes some input and performs some operations on using the input and produces an output. So as most of you have already known about things like calculator or a computer. So calculator, if you take an example, it takes inputs such as numbers and operations like addition, subtraction, multiplication, division. Those are some basic things that calculator does. And it produces an output by adding two numbers, multiplying two numbers, or dividing two numbers. So similarly, we define these algorithms as a step-by-step procedure or a set of rules to obtain an expected output from a given input. What is a pseudocode? A pseudocode is something like a step-by-step written procedure to perform a given task or to solve a problem. So before you actually go and implement a solution to a problem using any high-level programming languages like C, Java, C++, basically it is always good to write a pseudocode which could be written in a plain English kind of language, which gives you an understanding of how you can implement this algorithm in a high-level programming language using a basic language like English. Let's say in this example, we have to make a decision based on a condition. The condition is like if sugar is required, then you add sugar, else you don't add sugar. Let's say you're doing a recipe, you're making a recipe and you want to add sugar, you don't know whether to add sugar or not. So when you look at the manual or instruction, you think that if you want to add sugar to the recipe, then you need to add sugar. If it is not required, then you don't add sugar to the recipe. So if this instruction is given to a machine like a computer, how does it make that decision? As a human being, you have your intuition to make that decision, but a computer system should be fed with instructions such as the conditions, right? So this example talks about how you actually go and define a pseudocode. So when it comes back to algorithms, there are various kinds of algorithms in the real world. One such algorithm is pattern is sorting. Sorting is nothing but arranging a group of items in a particular order based on their size, their shape, the color, etc. In this example, we have taken books. So you can sort or you can arrange the books by their size, by shape, or color. So if you look at the picture, there are two different ways of performing the sorting. One is manually, like a human being actually sorting the books. And if you go and look at an online store like Amazon.com and you want to purchase an ebook like an electronic book, you can search and you can sort based on the kind of book that you want to read, based on the genre, based on the price, etc. So sorting is nothing different than manually sorting things to put them in a particular order. So computer system also does the same thing. using these sorting techniques. There are different kinds of sorting algorithms that we are going to learn in the future video, but this is a very basic example to get an understanding of what is sorting. Moving on to the next paradigm, search. Search is a paradigm of algorithmic design where you want to find a data in a given set of values, within a given set of values. Let's say you are searching for a word or a phrase in Google. So in the background, the Google search engine by default, as its name suggests, it searches for the particular data based on the word or phrase you're entering. Let's say you're trying to search for a weather report, or you want to search for a particular university or a hotel. It takes the input of these words or phrases and it performs a search in the background based on the data that is available in Google, and it gives you the results. That is how searching works. Divide and conquer. This is an interesting paradigm of algorithmic design where a given problem is broken down into subproblems of the same or related type, and once you find the solutions to these subproblems, you combine them to solve the original problem. For example, in this picture you see a person is solving a Rubik's cube. So for solving a Rubik's cube means all the colors should be available at their place. For example, the cube should be in such a way that all the colors are aligned properly. So if the person is given a zigzagged Rubik's cube, he has to sort them by their color and arrange all the colors in their order, such a way that the Rubik's cube is shown as when it is new, or when it is in an original state. So to do this, we have to solve the Rubik's cube in a phase-by-phase manner, which eventually produces an end result where the Rubik's cube is completely solved. So divide and conquer paradigm is applied here, where you break down the solution into different parts, like solving each phase of the Rubik's cube, which finally helps you to solve the entire cube. The next interesting algorithmic pattern is backtracking. This is a technique used to solve a given problem to build a solution recursively. Recursion means doing the same thing again and again within its same context. And then if you are not able to solve the problem at any point of time, you go back, that is you backtrack or you trace back to the original state of the problem and then find a different other solution to move on. So for example, you can think about solving a Sudoku puzzle where a person trying to solve a Sudoku puzzle will go and insert the numbers from 1 to 9 in a particular row or a column, making sure that there is no interference of the digit with the other digits. So if he or she is not able to solve that particular row or column, they will go back and they have to readjust their numbers to solve the entire grid. Similarly, there is another kind of a problem called 8 queens. So if you imagine a chessboard with 8 queens to be placed, one in each row where they are not interfering with each other, this shows the way they need to be arranged. However, when you initially start arranging these queens on the board, you might end up in cases where any two queens are contradicting with their places. So in such cases, you have to remove the queens which are contradicting and then go back to the original board and reorder them in such a way that you could solve them where no queen is interfering with the other one. Another best example is solving a maze. Let's suppose you are in a maze. You want to go from a starting point to a destination. And when you start entering the maze, at some point of time, you might be in a position where you are blocked and you don't have a way to get out of it. So what you do normally is go back and find a new route where you go and explore the new route and see if there are no bottlenecks or any blocks in between so that you could reach the destination. So finally, at one point of time, after exploring all the possibilities, you will go to your destination in the maze or you will solve the maze. This kind of approach is called backtracking, where you are moving back to your original state when you are blocked and exploring the remaining states. Another important algorithmic pattern is greedy. So greedy algorithms are used to solve a problem with an optimum solution in such a way that the decisions are made from the solution where you have different options to take care of, but you will choose an option which produces an optimum solution in a greedy way. So let's say you are given, in this example, if you see, you have a bag which weighs 15 kilograms and you have different size of blocks with different weights and different prices. So in a given problem, what is the maximum value that you can obtain without exceeding the 15 kgs of weight in the bag? So you have to pick the blocks where the total value is maximum, but the weight should not exceed more than 15 kgs. In that case, if you see, if you pick 12 kg block, which is $4, and then you are left with only 3 more kgs. So the total money you will be getting out of 15 kgs is 4 plus 2 plus 1, like 12 kgs plus 2 kgs plus 1 kgs is giving you $7. There are different other options that you can explore where you would get more money than $7 in this case. But in a greedy solution, you always go and look for an optimal variable where you want to take the 12 kg weight, which gives a maximum weight, which has maximum money. But you never know. For example, the 4 kg block has $10. Choosing that would give you maximum money in this case. So if you take a 4 kg block and then put the remaining weights, it's obviously more than 7 kgs, $7, which is the 4 kgs is having $10. So you would definitely earn more money by putting the 15 kgs weight into the bag. So this is called a greedy approach, finding an optimal solution for a given problem. But unfortunately, greedy solutions do not always yield the optimal solution or the best solution for the entire problem. When you make a choice, there is always a chance of selecting the 12 kgs block instead of selecting the 4 kgs block. So in later videos, we will discuss more about the greedy problems and their solutions. Moving on to graph algorithms. Graph algorithms are different kinds of algorithms which are mostly impacting our real life today. Some examples are like Facebook is an application where people are connected to each other as friends and friends of friends and mutual friends, etc. So these graphs are used to represent the network, such as relationships in applications like Facebook, Instagram, LinkedIn, etc. Similarly, the graphs are also used to represent networks like paths in the city, which is basically used in maps, applications like maps such as Google Maps, Bing Maps, where if you want to travel from a source to a destination, you would definitely need a routing path. So this path is represented as a graph in a real world computational problem, and the systems like GPS applications or any other applications which are solving these problems will represent the data in a form of a graph. A graph basically consists of a node and an edge. Edge is nothing but a path between 2 points. A node is nothing but a path. For example, in the above map, if you see, you have different pins, and you can assume those pins as nodes, and the red path which is connecting two different pins is an edge or a path. So in such ways, graphs are being used in a real world day-to-day life. So thanks for watching this video, and in my next video we will go deep dive into various types of algorithms and their implementations. Thank you.